This is going to be a tough nut to crack, so I want all of you to focus in this video right till the end. बिल्कुल ध्यान से देखें and better watch this video at a higher pace, preferably 1.25x. Okay, so if you are a student of engineering mechanics, you must watch this video right till the end, as it is going to clear your concepts and confusions of friction in statics in engineering mechanics. And here we go. So there is a 3 kilonewton machine part which is placed on block A. Okay, 3 kilonewton machine part on block A, which rests above wedge B. Okay, take mu is equal to 0.25 for all surfaces in contact. Now there are 3 things which have been asked. This is not one single problem, but a combination of 3: part A, part B, and part C. And we are going to comprehensively make their free body diagrams, okay, all of them, and their solutions I'll be discussing in detail. So be patient and stay with me right till the end. It will take around 15 to 20 minutes, to be very honest. Okay, the first thing, find the smallest force P needed to raise the block A when theta is equal to 45. Okay, then read this. Find the smallest force P needed to hold the system in equilibrium when theta is equal to 45. So, what is the difference? Will the answer be different in both the cases? The answer is different because the descriptions are different, and the free body diagrams that you guys are going to create with me will also be different. First of all, take a look at this once again. Always, in any subject, read the question multiple times unless you are absolutely satisfied that you can go ahead and crack it. Find the smallest force P needed to raise the block A when theta is equal to 45. When I say raise the block, the impending motion will be in this direction, impending motion. If this goes upwards, block B, impending motion is to the left. If block B starts moving towards the left, the friction will be over here from the ground on block B. To prevent that from happening, okay, to prevent the block B from moving in the left hand side, the friction will be to the right, and here the friction will be up the incline. The complementary friction on block A will be down the incline, and here, since it is going to just start to slip in the upward direction, the friction will be offered from the wall onto this block A will be in the downward direction. So this is how you can work this out. Secondly, you've been asked smallest force P needed to hold the system. When do you have to hold anybody? Let's say you are lifting someone. That means what are you doing? You're trying to, balance yourself by holding their body weight upon you, isn't it? Isn't this right? So the natural tendency of block A would be to move in the, or to just start sliding in the downward direction. In that case, the natural tendency of block B will be towards the right hand side. This is the impending motion. This is the impending motion. And as you can clearly observe that in the previous case, the impending motion here was left, and here it was in the upward direction, and now it is absolutely opposite. So completely direction reversal will take place. Now, since it will going to slide, just start sliding to the right, the friction from the ground will be to the left. The friction from this block A will be somewhere down the plane, and this is the complementary friction up the plane on block A from block B, and here, since it is sliding in the downward direction, the friction here will be upwards. Now you can clearly see what these two statements mean. Here, raise the block A, and here, hold the system. That means the block A's natural tendency will come into effect. It will start to slide in the downward direction. So both the cases are different. Now I'll be discussing both of them, in fact all of them, in detail. Here we go. Smallest force P, very important word, raise the block. ऊपर उठाना है, ठीक है, ऊपर स्लाइड करवाना है, जस्ट स्लाइड करवाना है, तो कितना फोर्स लगेगा ये निकाल के बताना है. And by the way, this video is also available in Hindi. You'll find the link in the description. Okay, that channel's name is BTech Plus, right? All right, here we go. What do we do now? Separate both the bodies, and before that, let me tell you, these are the 3 contacting surfaces. So obviously you are going to get normal reactions. Let me free them. These are the normal reactions: R1, R2, and R3. This R2 is from B to A. This R2 is from A to B. That is the only difference. Okay. So far, so good. Now what we'll do is take a look. This is the impending motion. friction to the right. Okay, if this is R3, this is mu R. And here also friction is going to be up the plane. So onto block A, the friction, this complementary friction will have down the plane. And here, since the motion will impend in the upward direction, the friction from the wall on block A will be in the downward direction. If this is R1, this is mu R, and we know mu's value is 0.25. We know this. Now, the next best thing to do is to resolve the force into components this way. Take a look. Angle, the side in front of the angle is the sine component. If this is 45, this is 0.25 R2. This has got to be 0.25 R2 sine 45. And the side remaining is the cos component. Similarly, take a look over here. If this is R2, angle is 45. The side in front is here. So this is going to be sine component, R2 sine 45. So damn easy. Okay. You could have gone this way also. You could have gone horizontal and then vertically downwards. In that case also, you are going to get the same results. No difference whatsoever. Let us now focus on this block A. Okay. Now what's up? Let me start with summation fx0. If you watch, R1 is to the right. That's why positive. R2, this force and this force, both of them are to the left. That's why negative. Is there any other horizontal force? No, sir. None. So just write them down with their proper signs. Okay. Now you can simplify for R2. R1 will be is equal to 0.88 R2. We are going to be using this result. Summation Fy is equal to 0. Minus 3 kilonewton. Why? It is going downwards. That's why. Minus 0.25 R1. Minus 0.25 R2 sine 45. Plus R2 sine 45. Watch. Write all of these forces down with their proper signs and equate them to 0. Okay. Now what we can do is we can put this value over here. But before that, you can simplify this further. And when you do that, this is what you get. Now let's put the value of R1. R1 is 0.88 R2. Let's put it over here. Done. It becomes very simple now. There is one equation and there is one unknown, that is R2. And this is what the value of final value of R2 will be. 9.67. Yaad rakhna. 9.67 kilonewtons. Remember this. When you put this value over here, the corresponding value of R1 is going to be 8.51. We need this value, 9.67. Let me now go back to the original free body diagram. Okay. In just a second. This was the original free body diagram. And now we are going to focus on this block B. Let's start. Here we go. Block B. Okay. What shall we do? Sir, what we can do basically is we can start with an equation of equilibrium. How do you start? Watch. Summation Fy. Sir, why have you gone for summation Fy and why not summation Fx is equal to 0? The reason being very simple. Along this y direction, I can clearly see R2 value is known to us. What is the value of R2, sir? R2 happens to be 9.67. I'm going to use it. That means it is known. Okay. Fair enough. And along this direction, y direction, R3 is unknown to us. So from summation Fy is equal to 0, there is one equation and there is one unknown. Better to solve this first. Get the value of R3. Okay. And then we'll be discussing summation Fx. So this is a downwards negative. This is upwards positive. This is upwards positive R3. Any other force in the vertical direction? No, sir. Write them down. Now you can see R2. R2's value is known to us. What is R2, sir? Here it is. 9.67. So let me put this value 9.67 over here. We are going to solve for R3. R3 will be equal to 5.13. Done and dusted. Now let's go for summation Fx is equal to 0. And when you do that, if you watch carefully, R2 cos 45, this is positive. 0.25 R2 cos 45, positive again. 0.25 R3, positive. But there is one negative force, that is force P itself, whose value we are looking for. Let me write them down. Done. R2 value is known to us. 9.67, 9.67. What about R3? This is R3. 5.13. Let me plug in all of these values. You can see the color code yourself. and then you just need to solve for P. P's value is going to be 9.83. Isn't it easy? That means onto this arrangement, if you apply a force of 9.83 kilonewton here, if you apply this force of 9.83 kilonewton, this block B will will just start to slide to the left, causing block A to just start to slide in the upward direction. That means it has risen. Okay, and that is exactly what was asked in the question. Find the smallest force P needed to raise the block A when theta is equal to 45 degrees. So in the first 10 minutes, we have finished the part A of the problem. I am very much sure that you guys now have a fair idea as to how to approach a problem when this term raising a block has been written through a wedge. Let me now talk about part B. In part B, we've been asked to find the smallest force P needed to hold the system in equilibrium. System ko hold karke rakhna. How will this take place? Especially when angle theta is equal to 45 degrees. So take a look. You need to hold the system together. That means, when do you have to hold something? You have to hold something when something is falling down. Okay, or it is about to crumble, it is about to fall down. In that case, block A will have a tendency or motion, impending motion in the downward direction, which thereby causes block B towards the right. If this is the case, block A is going to have friction from the wall in the upward direction and here up the plane. The complementary on block B will be down the plane, and here the friction will be towards the left. Okay, if it is going to just start sliding towards the right, the ground will prevent it from happening, thereby causing a friction to the left. Okay, and here the wall is preventing such impending motion. Always remember, friction is opposite to this impending motion. Remember. So far so good. Separate both of them. Fix the reactions. Impending motion, sir, downward to the right. So impending motion is to the right, therefore friction to the left. Here also. Complementary upwards, and here downwards, friction upwards. Done. So damn easy. Alright. Now you just need to worry about the components. Watch, you can go from this and this. Okay, you can make components like this. Okay, this is going to be the sine component, this will be the cos component. It's so damn easy. So this way, just think about all of them. Pause the video right now, pinch on the screen, you will be able to zoom in, and then you can yourself work out all of these components. Right, this is 45 degree. The side in front will have a sine component, so 0.25 R2 sine 45. Okay, now I think we should focus on block A, and let us try to analyze this. Summation fx0. R1 is positive since it is to the right. 0.25 R2 cos 45 positive again. R2 cos 45 negative. Is there any other horizontal force? No sir. Let me write them down. Okay, you can take R2 as common, or you can you have to take R2 as common, and you need to simplify this. Now let's go for summation Fy is equal to 0. Downwards, upwards, upwards, upwards. Write them down. Okay, you can simplify R2. Right, done. R1 is 0.53. Write it over here. Again, there is one single equation and only one unknown, that is R2. Solve for R2. This is what you get, and put the value of R2 over here, and you are going to immediately have the value of R1. Done. This is what it is. Easy, easy. I'm sure if you are this way through the video, 15 minutes down, you have found a little bit of confidence as far as problem solving in friction is concerned. Okay, I congratulate for you. Okay, in this world of shorts and reels, you have the patience to watch a video for 15 minutes. A thumbs up from my side for all of you. Right, let's go ahead. Take a look at block B now. whatever we had to do with block A, we have done. We've got the values of R1 and R2. Now let's focus on block B. What we'll do is we'll go for summation F5 first. The reason being very simple, because R2 is known to us. How much is R2? Take a look. R2 is 2.95. We are going to use that value over here. And when I use it in this summation F50 along the Y direction, okay, this is positive Y, this is negative Y. What I see is this is known to me. There is only one unknown. When I apply summation F5 is equal to 0, if you want to zoom in, let me just show this to you. If you analyze all the forces in the Y direction, R2 is known, R2 is known. There is only one unknown, that is R3. So immediately by using this Fy alone, you will be able to calculate the unknown value. So this is downwards negative, this is upwards positive, and just write them down with their proper signs. Okay. Put the value of R2, 2.95. Solve for R3. This is what you get. Go for summation Fx0. When you do that, plus R2 cos 45 minus, this is minus by the way, the direction of arrow is to the left, and then minus 0.25 R3 minus P. Okay, I think we've covered all the horizontal forces. One is positive where the remaining three are negative. You will see this. Done. Done, so. Now, time to put the value of R2. How much, sir? 2.95. Put it over here at these two locations, and then you've got R3. Okay, you can put this value 2.61 in. So punch them in over here, and you are going to find the value of P. P works out as 0.912. Sir, we have got the answer, but can you explain this answer? How much? 0.912. What message, what meaning does this answer convey? 0.912. It essentially means that if you apply a force equal to 0.912, this block B will just start, the motion will impend to the left, and here the motion will impend in the upward. No. This problem was basically, let me read the problem description. The impending motion was already known to you. So here, this was the impending motion. And block B, this was the impending motion. You just had to apply sufficient force so that this force is able to hold these two blocks together. बस hold करके रखना है, इसको ऊपर नहीं उठाना है. Here the impending motion is not in the upward direction, rather it will take its natural course of action. The motion will impend in the downward direction, thereby causing block B to move in the right hand side direction. What we need to ensure is we need to apply sufficient force that this entire arrangement of two blocks stays in equilibrium. Okay, and that's why you saw the friction this way, right? Okay. So we are done with case B now. Let us now focus on the final case, part C. You cannot apply any force now. If P equals 0, find the angle theta for which sliding impends. Wonderful. For which sliding impends. Okay, so before I start moving with part C, let me tell you something. If you want to learn engineering mechanics in a very comprehensive manner, you can enroll in my course. All the lectures are there, all the chapters. I have covered a lot of things that Indian universities cover. I mean, a lot of coverage that I have done is from the syllabus prescribed by Indian universities. So if you are from Pune University, JNTU, or any other university across India, you will find a lot of content similar to your syllabus. So do check it out. The link of the application is in the description, so download it and enroll in the course, and don't be late. If your examinations are about to begin in the next 2 months or 1.5 months or even 1 month, enroll in the course, learn as much as possible. The lectures are available both in English and Hindi, so you'll be benefited, and even there are notes in PDF, high quality. Okay, to use the entire content and start learning. Don't be late in your preparation. जितना late होगे उतना दिक्कत हो जाएगी. Here we go. So when P is equal to 0, what do we need to do, sir? How much should theta be for which sliding impends? Listen to me. What if this was theta? What is your gut feeling? Sir, if the angle is too small, sir, then there won't be any sliding. Okay, let us increase the angle. Sir, it is possible that there may not be any sliding. If I keep on increasing the angle, a time will arrive when this angle is just sufficient to break the ice. That means the moment I increase the angle, they're up at a particular or a special theta, this block will slide, just start to slide in the downward direction, and this block be automatically, because of block A, will just start sliding to the right. Again, this is to the right, this is in the downward direction. Okay, so based on this impending motion, we can work out the direction of frictions, right? So damn easy. Let me free these bodies together. It is this angle theta that we are now interested in, and there is no P. Let me tell you very frankly. Okay, watch. Sir, impending motion. The last two cases, B and C, impending motion is same. Okay, in one case you had to find force P for holding the system in equilibrium, and in this case P is completely eliminated. It is rather this angle theta that we are interested in. For what theta? Slipping impinge. Okay, block A starts slipping in the downward direction. Wonderful. So if this moves to the right, the friction will be to the left, and before that, let me fix the normal reactions. Friction here will be to the left, down the plane. If here it is at down the plane on block A, from block B, the friction will be up the plane. If it is going to move in the downward direction, if the motion impends in the downward direction, the friction from the wall will be in the upward direction. Done. Sir, but what have you done over here? In the 45-degree case we saw, everywhere you had written 45, but how can you write theta over here, and how can you write 90 minus theta? I've got an explanation for everything. You don't have to worry. Okay, just watch. So here it is. Now, one thing that you've got to believe me is this angle is theta. Okay, let me explain you through this. This is theta. Okay, let me draw a vertical and let me extend a normal. This angle has also got to be theta. You can pinch on the screen and you can zoom it. If you're watching this on YouTube, you can pinch on the screen and you can zoom into this much portion. If this is theta, this is 90, this has got to be 90 minus theta. If this is 90 minus theta, again this angle is 90, this has got to be theta. If this is theta, then again this is 90 minus theta. If this is 90 minus theta, this is going to be theta. If this is theta, this has got to be 90 minus theta. As simple. In the similar fashion, you can work out, if this is theta, this has got to be 90 minus theta. But you have got to be very careful with the components. Resolving the forces into components. Watch. Sir, same thing. What is the same thing? Sir, the component on front of theta is the sine component. Yes, here it is true. And the one left is cos component. What about this? Sir, here in front of the angle, you have made the sine component, and here it is the cos component. Okay, just watch. Just a second. If you watch carefully, whatever I have told you, whatever instructions I had given, that the component in front is going to be sine component, but here it is no longer following. Why? The reason is very simple. Here the angle is 90 minus theta. So even if you apply, this is R2 by the way. Okay, just watch. R2, this component in front should be the sine component, sir. So sine of the angle is, sir, 90 minus theta. Since 90 minus theta is cos theta, therefore this is going to be R2 cos theta. This is the reason. Okay, I hope it's clear to everyone. And the similar case you are going to find somewhere along this force triangle also, right? Okay, now with that being said, now let us focus on this block B. I'm going to start with block B only, because if I focus on block A, I can see there are as many as 3 kilonewton, R1, R2, and then theta. 4 parameters. I hate more number of parameters. Instead, I'm going to go with block B. Block B has only 3 parameters, R2, R3, and theta. So it is easier to analyze block B first of all. Take a look. This is positive R2 sine theta. This is negative 0.25 R2 cos theta. This is negative 0.25 R3. Let me write them down. Done. Simplify this. How, sir, you can take R2 as common? Sin theta minus 0.25 cos theta. Okay, so this is what you get. Next, we are going to go for summation F50. If you watch carefully, again, this and this force over here. These two forces are in the downward direction, and hence negative. Plus R3. Is there any other force? No. Write them down. Can you simplify this? This is R2, R2. You can simplify this to a certain extent. Okay, so far so good. Now, students, what we are going to do is, we have this value of R3. This is the value of R3, by the way. We are going to put it over here. Right? R2 will cancel each other out. The one thing that we are left is, you can 0.25 multiply, get it multiplied inside, and this is what will happen. Now you simply need to put all the cosines together, all the sines together on opposite ends of the equal to sign. Go for tan theta. This is what you get. Do the inverse, and the value is 28.07. The moment this angle of the wedge touches 28.07 degrees, let me repeat, the moment the angle here touches 28.07 degrees, let's say you start with 0 degrees, you keep on increasing the value 10 degrees, you keep on increasing 20 degrees, and the moment it reaches 28.07 degrees, what will happen? Slipping impends in the downward direction for block A, which thereby causes slipping in block B towards the right hand side. Okay, so this was the beauty of the entire problem. So if you stayed with me, if you're watching this video right from the beginning, I would like to congratulate you for being very, very patient. As I told you before, in this world of shorts and reels, the concentration span of students, of everyone, every human being, has dipped quite a lot. So congratulations on that front. Okay, and yeah, if you find this video helpful, do like the video, share it with your friends, and subscribe to the channel. And if you want to learn engineering mechanics content in a very organized and a sophisticated manner, download the Manas Patnaik app. You'll find the link in the description down below. Thank you very much. Good day.